we have to remember that rate of change is the slope of a secant. And when we're talking about the estimate of the instantaneous rate of change, it's still slope. Rate of change is still slope. But in this case, because it's 0, we have 0 slope here. So the slope is 0, which indicates that it's a horizontal tangent. So when the slope of the tangent is 0, we know obviously that it's horizontal and there's no change, there's no increase or decrease. Think about the floor. The floor is horizontal, and well, there shouldn't be much of a slope to this, but floors in general should be horizontal and they should have no slope to them. Okay, so that's the same case here at this maximum. Okay? So the instantaneous rate of change is 0 at the maximum point. Now if you were to look at the left side of the curve, what would all the slopes, in terms of positive or negative, what would be all the slopes on the left side of the maximum be? Jen?
Positive.
Okay. So the so the slopes of the tangents to the left of the maximum would be positive. Okay, because as you know, as you're following along a curve from left to right, you're increasing up to that maximum. So as you increase, the slopes are positive, and then you get up to the top, you get that 0, and then what happens on the right side of the curve? Michael, as far as that? Yes. So the slopes of the tangents to the right the maximum would be negative. Okay, and of course the word slope and rate of change are interchangeable there. Okay, so if you take a look at a curve, and to the left of the maximum, you see that the rates of change are all positive here. You've got a positive slope as the tangent increases all the way up to the maximum. Right at the maximum point, we see we have a horizontal tangent with a slope of 0, or a rate of change of 0, and then as you continue the tangent along the curve to the right of the maximum, then the slopes become negative. Sure. Fred? That's okay. Okay, so we've kind of already got to this point already. But what would the tangent line look like at the point where maximum occurs on a graph? What does the tangent look like at a maximum point? Jamie Bailey, what do you think? Yes. Okay. So the tangent line we've already covered that, but it's good to kind of refresh your memory about that. Always keep in mind that instantaneous rate of change or average rate of change, those are just slopes. Okay, so rate of change is just slope. And tangent lines are where is a line that touches the curve at only one point. Okay, and that gives us the most accurate description of the rate of change of the curve at that point. Yes?
Is it okay if I
No. But now you may. Okay, now what about if we had a minimum? What could you use? How could you use tangents and the slopes of tangents around a curve to determine where a minimum, if you were just given a bunch of information about slopes of tangents, where they're positive, where they're negative, etc., how could you tell where a minimum occurs? Jonathan, thank you. Okay, let's take a look at where the maximum occurs. What happens with the slopes and tangents? The slopes and tangents to the left would be maximum, and slopes and tangents to the right would be minimum. Or sorry, negative. So to the left of the max, the slopes are positive, and to the right of the max, the slopes are negative. So what would you think around a minimum? So if you had some kind of graph, and it's the minimum, how do the slopes and the tangents, how are they in terms of positive and negative here? Jonathan, still? Yes.
Oh, I didn't hear your response.
Yes, I'm still asking you. You're not getting away with it.
If the slope on the left is negative,
let's make this complete. And what happens about on the right side? And what about on the right side?
positive slope on the right.
Then great, thank you. Okay, so chances are you'll see some type of question like this where you have to describe in painstaking detail where a maximum or a minimum occurs and how you know just by the signs of the tangents. So even though it's kind of like if it's a quadratic, you know that on one side of the vertex the slope is a negative, then obviously on the other side it's going to be a positive. But if you're just given a function, you don't know if it's a cubic, that it just continually decreases. So I'd like you to state that on the left side the slope is a negative, on the right side the slope is a positive, therefore the point in between is going to be a minimum. And that at that point, at the minimum point, a horizontal tangent. So state about the horizontal tangent with a slope of 0. So bless you. So the more detail you put into your answers, the better. Basically, the better you understand it, and the better I understand you. Any questions about those follow-up questions to the graph?